Our planet Earth is, so far, the only habitable planet we know. Starting with our own solar system, we've been trying to find a habitable planet other than our own. Who knows? Maybe on some worlds, like Jupiter's moon Europa with oceans beneath its surface, life has already formed, but is still waiting to be discovered. Even so, up to now, we haven't managed to find life on any planet in our solar system other than Earth. What's more, we have to accept that none of those planets are truly, fully habitable in the strict sense. Still, if you follow science news on social media, you've surely come across headlines about new exoplanets discovered by scientists. You might even have seen some described as Earth-like planets. But there's a catch. When you look at how far those exoplanets are, they're usually hundreds, even thousands, of light years away. A light year is the distance light can travel in a year at light speed, so at those distances, we can't realistically even dream about reaching such planets. So where exactly is the closest planet outside our solar system, the closest exoplanet to us, and how far away is it? Is it possible to reach it? And if we could go there, could we adapt to that planet and actually live on it? If humanity set itself a goal like this one day in the future, how realistic would it be? In other words, if things went south one day and we had to abandon Earth, could we find a home to escape to outside our solar system? Today we're going to take a fun trip into space and answer those questions together. But before we dive into what might be one of humanity's most important goals, I want you to take a moment to think about your own goals. For example, do you have 2-year, 5-year, or 10-year goals? And do you know what you need to do to reach them? Of course, everyone may have their own methods for their goals. But there's a truth that applies to everybody. Developing yourself in different areas will help you reach your goals. Where would be the most logical place in the sky to look for the closest planet to us outside the solar system? Naturally, we'd look right at the closest star to us in the sky. As you know, stars form in space when gas and dust clouds accumulate under the influence of gravity. But not all of the matter in those star-forming regions always collapses enough to trigger nuclear fusion. In that case, within the same gas and dust cloud, planets that can't generate their own energy also form. In short, since we know how stars form, we can also say that along with stars there should almost always be planets or moons of various sizes that form with them. So based on this, we can say that nearly every star we see in the sky should have at least one planet around it. With that in mind, if we study the closest star in the sky with the right observing techniques and enough detail, we can find planets there. Let's talk a bit about the closest star. The star closest to the solar system is Proxima Centauri, about 4.2 light-years away, roughly 40 trillion kilometers. However, this star is in the constellation Centaurus, which is visible only partly from the northern hemisphere. Turkey is in the northern hemisphere, so we can't see Proxima Centauri in Turkey's sky. Even if it were in the northern sky, this star would still be hard to spot, because with an apparent magnitude of 11, Proxima Centauri is too faint to be seen with the naked eye. At this point, you might wonder, if it's the closest star to the Sun, why does it look so faint? Because Proxima Centauri is an M-type red dwarf star. Red dwarfs are the most common type of star in the universe, but they're both small and low luminosity. Since their sizes and masses are relatively low, red dwarfs are cooler stars and they don't burn through their fuel quickly like big stars do. In fact, for example, if Proxima Centauri keeps up its fusion process at its current pace, it will continue to shine for a few trillion more years. So we can say that red dwarfs are relatively quiet stars. This quietness of red dwarfs opens up an interesting possibility. When we talk about the possibility of life in space, to get life on a planet, we want that planet to be in the so-called habitable zone, not too close to and not too far from its star. At least for us to be able to live there, that's the minimum. In this region, there's a chance for liquid water to exist on the planet's surface, because the temperature range needed so water doesn't freeze or boil is provided in that zone. Since red dwarf stars are relatively cool, the habitable zone where liquid water can exist can be quite close to a red dwarf. Indeed, when we look at Proxima Centauri b, the exoplanet discovered in 2016 around the star Proxima Centauri, we see that this exoplanet is very close to its star. Proxima b completes one full orbit around its star in just 11 days. In other words, a year on Proxima b lasts only 11 days. So this exoplanet orbits just 7 million kilometers from its star. For comparison, for example, even Mercury, the closest planet to the Sun in our own system, has an average distance of about 58 million kilometers from the Sun. Despite being this close to its star, we can still talk about a possibility of habitability for Proxima b, because unlike our Sun, Proxima Centauri is a much cooler star. Proxima Centauri's surface temperature is around 2,800 degrees Celsius. For comparison, our Sun's surface temperature is much higher. One of the most important criteria for the possibility of life or habitability on Proxima Centauri b is the planet's mass. Roughly speaking, the greater a planet's mass, the more atmosphere it can hold. That's very important for habitability because a planet's atmosphere directly affects the planet's climate. Looking at the mass of Proxima Centauri b, we see it's a little more massive than Earth. Its mass is measured at about 1.27 Earth masses. In other words, that mass points to the planet having a rocky, Earth-like surface and also having an atmosphere. But let's pause a second. Up to this point, I've given you fairly complex information about Proxima Centauri b, its size, mass, atmosphere, and more. But seriously, how do we know all this? For example, we don't even have a photo of Proxima Centauri b. Only about 10 years ago did the Hubble Space Telescope take the clearest photo of Proxima Centauri, the star, and in that photo we see only the star, not the planet. So where and how are we learning all these details? There are many different methods used to discover exoplanets. Proxima Centauri b was discovered using a method called the radial velocity method. All planets are in a tug-of-war with their host stars via gravity, causing the star to make a kind of wobbling motion. Red dwarfs are small, relatively low-mass stars, so a planet around one will have a much more noticeable gravitational effect than Earth's effect on the Sun. As the star moves toward us, its light shifts toward bluer frequencies due to the Doppler effect. As it moves away, the light shifts toward the red. From this pattern, scientists can infer the presence of a planet, and because the star's radial speed is measured, this technique is called the radial velocity method. Since the phenomenon underlying this method is mass, we can also estimate the planet's mass, not just detect it. The higher the planet's mass, or the closer it is to its star, the larger the observed swings toward red and blue, meaning the more the star wobbles, the more massive the planet. Since mass is a key criterion for clues about a planet's atmosphere and whether it's rocky, these details can be teased out using this method. So, to quickly summarize what we know about Proxima Centauri b from this technique, even though it's very close to its star, it's in the habitable zone. That means it's possible there's plenty of liquid water on its surface. Its mass is a bit greater than Earth's, so it likely has an atmosphere and is a rocky world. In light of this information, it's reasonable to call Proxima Centauri b the closest potentially habitable planet, or a super-Earth, near us. However, we still need to mention some factors that could reduce its habitability. Let's start with an odd situation the planet may be dealing with. Because Proxima Centauri b is so close to its star, a tidal lock has likely formed, meaning the planet always shows the same face to its star. That could cause the star-facing side to be extremely hot and the dark side extremely cold, obviously bad for habitability. However, thanks to the planet's atmosphere, winds may distribute heat across the surface more evenly, potentially balancing temperatures out. In other words, tidal locking may not be the biggest threat to habitability here. There's a bigger one. Even though red dwarfs are relatively quiet, active ones like Proxima Centauri can unleash powerful plasma outbursts. We're basically talking about the same kind of solar flares our sun sometimes emits that make people nervous. If a red dwarf like Proxima Centauri produces such activity at much closer distances to its planet, it can strip that planet's atmosphere away. If Proxima b has a strong magnetic field, like Earth does, it could be protected from such stellar outbursts. But we don't know for sure. Up to this point, we've talked about the possibility of habitability on Proxima b. I want to remind you that the possibility of life on a planet and the possibility of habitability are different things. In this video, we focused on a narrower question. If we went to Proxima b one day, would we find an environment there that's habitable? Could we live there? Looking at the ideal ingredients we'd need, gravity in the right range, a rocky surface, an atmosphere, and liquid water, we can see that Proxima b appears to tick those boxes. So, summing it up, yes, it seems quite possible. If we ever had the chance to go to Proxima Centauri b, we might see oceans, rivers, or continents under the protection of a strong atmosphere. At least, this is where current scientific data leads our best estimates for now. Proxima Centauri b really could be the closest habitable planet to us. But if we truly wanted to go to Proxima Centauri b one day, how long would that trip take, even in the best-case scenario? With today's or near-future technology, could we actually get to the closest habitable planet? Let's dig into those questions in the next video, as a separate topic that continues from this one. See you in the next video. Bye for now.